Welcome to our second session on transitioning to text. In the previous session, we looked at some of the most common barriers to this transition, as well as some approaches and techniques for teaching and learning that can help minimise them for pupils in Key Stage 3. And this session continues to examine ways in which we as teachers can help make this crucial transition as smooth as possible. Although there isn't time in this short video to go through everything that is covered in the session and in the detail it is covered, I want to give you a taste of just what it explores and just how it can provide you with focused, meaningful and practical professional development, and all through hands-on investigations developed in classrooms by teachers, each of which have proved successful in Key Stage 3 and above, in order to give you a heads up to those areas covered so that you can go away with new perspectives and get the most from the session when you get to work through it as a whole. Our prime focus is on empowering teachers of computer science. Whether you are new to teaching computing or just want some new ideas and approaches, the session will help provide techniques, resources and ideas which you can draw upon and adapt to enrich your own Key Stage 3 lessons or that of your department or learning community as a whole. At the same time, I will leave it up to you as teachers to judge which of these are most appropriate for your own pupils and at which age you think the activities might work best for them. To find out more about this session or any other and how to take full advantage of them, please visit Tenderfoot Online. The link to this will be in the description below the video and will also appear throughout, as well as at the end, as will links to CAS Online, which you can join and become part of our growing grassroots community. But for now, let's look at more ways to assist pupils when transitioning to text. We firmly believe in helping you to develop your own practice through clear, focused outcomes that you can go away with and use directly in the classroom. In this session, these outcomes are recognising the key concepts and constructs for tackling programming challenges, appreciating some of the barriers for children learning to code, be familiar with the Turtle system, a tool to assist the transition to text-based coding, and to have explored a range of activities for introducing programming concepts at Key Stage 3 and upwards, with each of these linked to practical classroom activities that are designed to help your pupils progress. Along with these core outcomes, the session also illustrates the role that computational thinking plays in the teaching of computer science, and in context so that you can use it directly to enrich pupils' learning and enable them to really think like computer scientists. In the previous session on transitioning to text, we looked at some of the main barriers for children, along with approaches proven to help create a smoother transition to text-based programming. We also explored how a gradual, scaffolded approach to learning, with opportunities to revisit and repeat learning in different contexts, can best enable pupils to manage the cognitive load they face during this transition. You see, not only do pupils in Key Stage 3 need to learn new concepts and constructs, but they also need to learn the text-based languages that they are written in. And if this is not handled in a structured and gradual sense, then it will come as no surprise that pupils can feel intimidated and may come to believe that this transition is a hurdle they cannot cross. In this session, we will continue to explore these potential barriers and look at how the role of reading code can help them progress more readily, along with a range of practical techniques that involve reading code, analysing it and predicting what it does, and then observing how that code runs and reasoning about the outcomes. With this in mind, the session begins with a quick consideration of the legacy of Seymour Papert, the inventor of Logo and Turtle Graphics, and his wider ideas about pedagogy. We begin by reflecting on his core ideas about constructivism and constructivist teaching, and how this approach is shown to improve how children learn about the world around them. The particular area of this approach we're interested in here is that children learn through constructing mental models in the course of building things, essentially that they learn through doing, rather than simply being told or instructed on how to do something. Here, children succeed as they build their own mental models and toolkits through scaffolded experience and constructing meaning as they do so. This is a model that sees students as active learners, where they can learn more effectively through doing and not being told, and it is central to how we can help our pupils achieve success in computer science. As the session unpacks, it is through this transition to text where reading can play a central role in enabling children to progress satisfactorily and without feeling too intimidated. In fact, whether it is text-based, block-based or even unplugged, wherever you are dealing with constructs and algorithms, the reading, predicting and observing of this code should be a foundational core element of our toolkit and children's approach to learning. Just like shared reading and writing and literacy, reading code in a scaffolded and shared environment helps promote greater discussion, spread the cognitive load, and helps misconceptions to be spotted more readily, and for pupils to share their ideas, observations, and support one another in the construction of meaning. We'll also help them to build a deeper understanding and, in this case, a greater awareness of syntax that can help make the syntax barrier less intimidating for them. In this particular session, we will look at these techniques and approaches to reading code using a programming environment called Turtle System. Here it is. Now, Turtle supports programs written in 3 real programming languages, but for this session, we will be focusing on BASIC for our examples and investigations. The reason we chose Turtle is simply because it is designed specifically to support introductory programming through the exploration of graphics. And, as the session illustrates, Turtle offers us some really useful approaches and tools to help make the transition to text smoother for students, especially given its focus on graphical creation and how this can really engage pupils and offer us the power of immediate graphical output. At the same time, however, the approaches and ideas explored are in no way tied to the Turtle environment alone and are completely transferable to any context in which written code is being taught in Key Stage 3. You might already know the Turtle system, but even if you do not, this is no problem, as the session looks at just how we might introduce any new text-based environment to pupils, just as we might introduce it to any new learner, maybe even to learners like ourselves. In fact, we begin by looking at the value of generating class discussion around exploring new and unfamiliar programs like this before we allow children to create with them. You see, this initial investigation of software, where we look at things it might share in common with others, and where it might be different, is a valuable phase in the process in itself. It not only helps pupils navigate the program more successfully when going forward themselves, but it can also model ways which will help them hone their investigatory skills and powers as they progress. Following this, the session goes on to look directly at the value of reading code in the learning process. So, let's load a file and look at one of the initial challenges that we can display to pupils. Here, we just want to begin with the simple question of what will happen when this program is run. What happens here? Remembering that we want to guide discussion and predictions to be as precise as possible and for pupils to justify their reasoning. Then, once we have predictions, we can run the code. Here, a red circle outlined in black is repeatedly drawn that spirals outward in ever-increasing steps. We can then return to our students and discover how their predictions match the outcome and how and why they may not have. And here, where the predictions are wrong, we can help them reach into their mental toolkit to begin to reason about why it was wrong and help them to develop strategies required to debug their predictions and observations, helping them along the way to develop and employ logical deduction through observation and experimentation. This is another example that is covered in the session. Here we have the use of 2 repetition constructs, and with clear visual output, we can begin to appreciate how nested constructs execute, through the pupils predicting and observing what will happen, and then modifying their predictions with experience gained through that observation, all the time asking the students to explain each line of code, and, if a student translation of a line is vague, asking others to sharpen it. If it is still not precise, we can then model the correct answer, turning it into a collective challenge to hone the precision of their code reading. Once this initial prediction and observation is complete, we can then begin to modify the text ourselves, or ask students to do it, and continue the process of reading, predicting, and observing. How will this modified code act? What will happen? Why? As the full session explores, this helps to create a community of code readers that can work together and support one another's understanding and learning, something which can be harnessed and used in many powerful ways to learn, all of which is discussed and reflected on in the full session. What's more, each of these approaches can be used anywhere the code is written. Also, this approach to reading, predicting and analysing code acts as a perfect precursor for children to then begin writing code themselves, with the session going on to look at just how it links to pupils embarking on practical exercises by themselves, as a final step in this particular approach in transitioning to text-based coding. One such activity discussed in the session is called telling the time. By the time pupils come to this challenge, they will have already seen and observed all of the commands that are required to tackle it through the reading and observation of previous challenges covered in the session. But this time, they begin it from the point of view of a challenge, to write a program to display an analog clock whose minute hand ticks around. Although it isn't complex, and in many ways is just giving them repeated exposure of the same concepts in a different context, it will still be a challenge for them. Because, As the session makes clear, although the student will be revisiting code and constructs seen in other contexts, the challenge represents the student's first attempt to write their own text-based program, where the conceptual load will focus on the writing of that code. But even here, we do not expect the children to just go ahead and write blindly, because, as we explore, even here, even with previous exposure, the cognitive load will be too great and too many children will find it a barrier, mainly because of the syntax that is involved. At the same time, we wouldn't expect people to just go ahead and write in the real world. And, as with any software developer, the session looks at how the key to a successful program is to plan first, to help them piece together what they already know and how this can help solve the problem. At the same time, helping us to model with them the role of the key computational skill of decomposition, where they can break down the challenge into smaller chunks in order to make it more manageable. Again, a technique seen across real-world programming. Therefore, by the time pupils come to code themselves, they have gone through a process of analysing the environment, have had a chance to read and observe the code and syntax they will need, and the opportunity to have planned based on what they already know. At this point, they are truly ready to code independently, with real understanding and be able to make that transition with purpose. Yet, as teachers, we know that, however much we help clear the barriers for pupils, that during their first attempts at writing text-based programs, students will inevitably hit the syntax barrier. This is a given, and just part of the process. But again, we shouldn't expect pupils to cope with this unaided. The session explores how the mental toolkit developed in pupils while previously reading and analysing code can help them spot and correct these syntax errors. If not alone, then as a group or whole class. One more thing I'd like to mention before I go. For anyone interested in using the Turtle system, the session goes on to look at how teachers can also configure it to restrict menu options, which is an important feature allowing us to further take away the cognitive load of pupils. Another great strength of the Turtle system are the error messages it provides when there are issues with syntax. These are very precisely targeted, telling pupils what the problem is and exactly where to find it. This is really helpful when making that transition and helps them get across that syntax barrier. Finally, I'll return to our outcomes at the beginning of the session and say that through completing the session, you'll be armed with a number of clear outcomes, which you can then develop further in your classroom. These are recognising the key concepts and constructs for tackling programming challenges, appreciating some of the barriers for children learning to code, be familiar with the Turtle system, a tool to assist the transition to text-based coding, and to have explored a range of activities for introducing programming concepts at Key Stage 3 and upwards. Thank you for watching, and I wish you all the luck transitioning to text.